Hi, morning. Can everyone hear me? Yeah, cool, excellent. So one more talk about Kubernetes, right? Excellent. So essentially, we're going to talk a little bit more about tooling. Some of those have already been spoken at this conference, and if you've been attending to meetups and conference, some of these might be familiar. Let's hope that something here is useful to someone. And we'll try to demo some of these tools further along the talk. So just a little bit about me. I work at a company called Uphold. We are in the fintech space. We operate mostly in the crypto space, but we're starting to add new services. I'm one of the organizers of the DevOps Portal meetup. I used to only work on backend development. Now I'm more in the DevOps kind of stuff. I'm an open source passionate. I used to be a former Mozilla contributor. I do Taekwondo. I love metal. Thank you, Poland. And you can and you can find me here. You can talk to me afterwards. So a small plug, like a few seconds, because Uphold financed this trip for me and my colleague Rafael over there. We do operate in the crypto space. We are adding more financial services, moving more into fintech space. We have a mobile wallet. We have a web wallet. We have a new one coming up, so can just go and register. So let's start. So just a show of hands, who here uses Kubernetes in production? Just have an idea. So a few, yeah, excellent. So this might be familiar to some of you, just like a quick overview of how a Kubernetes cluster works. You have master and nodes. Usually you interact with a cluster via the API server, where you have a scheduler, which schedule your resources or jobs to run somewhere, and you have a controller, which actually will manage where the pods are running. In each node you have a kubelet, which manages the connections to the controller, and you have the kubeproxy to handle all the network connectivity. It has a few concepts, like pod, replica set, deployment. Most of you should be already familiar with that. If not, we can speak a little bit afterwards. That being said, you do need to actually know this lingo to actually get your applications running on a Kubernetes cluster. What is Helm? If you started like me, you started reading the Kubernetes documentation, you started finding out what a pod is, what a replica set is, what a deployment is, what a service is, and go back and so forth. And you started writing those files. You quickly discover that when you need to manage multiple versions of your application, you actually need to change those files, you actually need to copy and paste them to the other side if you have to maintain several versions. What Helm tries to do is actually define a structure to help you manage your services. So it defines the structure. It has a very concrete definition. It's easy to version and share and publish. So you can actually package those services and share them with everyone. And for me, one of the most interesting features was actually stopping the copy-paste madness. So you could have your version of your application staging, sandbox, production, feature branches, and you can actually just feed a shard with some config values, and you're good to go. Helm has a few components. It has the client, which you use on your own laptop or on your CI server. That connects to Chiller, which is an utility that runs on a Kubernetes cluster. You can actually just dry run your charts and see if everyone's okay, if rendering is working well. If everything is okay, Chiller connects to the API server and performs your deployment. So here's just an example of what a deployment looks like in Helm. So you just define the API version you're trying to use, the kind of resource. You can add a bunch of metadata, annotations. You specify how many replicas you want. You can put labels. You define your containers inside your pod. What image and version to use. You can add commands, args. You can have, envars, secrets, whatever is present on a deployment, you can define in Helm. So it's very simple. Minikube. How many of you here use Minikube? Excellent. So I don't use a Mac on a regular basis, so I don't have the luxury of having a Kubernetes cluster directly on Docker. So most of the times I'm using Minikube. So Minikube tries to have a small cluster running on your machine, so you can just test stuff out, see how your applications connect to each other, that kind of stuff. It's very easy to set it up. Yeah, Minikube, almost like Minikube start, and you're good to go. It automatically updates your kubeconfig to being able to use it. But you should only use it for testing, not production. And I've seen it being used in production, so be advised. So this is very simplistic of how Minikube works. It's basically a VM. You basically have your it replicates a master and a node. It has an API server, has a local kube to emulate all the Kubernetes functions, and you have a container runtime. Can be Docker or whatever you're using, and it basically functions for the client side as a Kubernetes cluster. So it's a nice way to test your stuff out. Skaffold. It's a project started by Google, so it aims at automating how you do your builds and your deploys. Most of us might be using some kind of CI server. You're basically tied down to that, whatever that CI server does. You're using some bash scripts. Skaffold aims to abstract all of those and actually having a very easy way to actually build your containers, push to a registry. Here's your shard. Go deploy this to production or whatever environment. Basically, it has 2 modes. It's the run mode and the build mode and run mode. So basically, you can have these stages. You can run scaffold build, and it will actually look at you can specify where the Docker file is. It will build it. It will push it. Or you can have it in dev mode, and it basically works like whenever a change is done, it basically automatically builds and pushes it directly to a cluster or your Minikube or wherever it is. So this is an example of a file in Skaffold. So basically just saying, okay, this is the artifact that I want to build. You can actually skip push, or it will push automatically. You can set envars. You can have a deploy stage where you can just say, okay, so this is the name of my resource. I have a Helm chart or just a file. I'm using Helm charts, and just do a deploy. So it's quite simple still lacking a lot of features, but it's a project that promises a lot. Last but not least, we have Telepresence. I think that Telepresence was mentioned by you yesterday, wasn't it? Awesome, isn't it? Yeah, it's we're basically starting to use it mostly for development purposes. So what Telepresence aims to use is like you have your own dev environment, like working as it was in a Kubernetes cluster. It's better if I show you a diagram. So during a development phase, you basically have your code. You want to test it out. You do a PR or just have it using a feature branch. You produce a Docker image using kubectl or whatever tool you use. You just push your Docker images to the registry. You do a deploy. You test it out. Everything works okay. You can just merge the code, push it to production. Or there's a bug. You do a new Docker image with more logging, some testing, just going out, push it out. Everything is okay. Rolling back. That takes time. Even if it is automated, it takes a little bit of time. This is what Telepresence proposes. So basically, your source code runs on a local process. It has a proxy to your Kubernetes cluster. You can have 2 modes. You can launch it as a new deployment, or you can actually override a deployment. So it's very useful in development stages where you have some processing staging that's not behaving well. You need more logging, for example. You can just override that pod, put more logging, see that actually happening on your machine. Find a fix, PR, just go. So basically, this is what Telepresence aims to do. So this is all fun and games, but we actually want to see something. Let's try and do a little bit of a project. Like I said, I work at a company that works in the crypto space. So this is the project that we're actually trying to build. So we have some service that we don't know what it is. That's fetching transactions from an exchange. Here we have a few. It puts on a message queue, and our project will be just some app that consumes these messages and tries to store it, in our case, in InfluxDB. Like I said, this is not my laptop, so what we're trying to do is not to break anything. I'll just now switch to a console, and it's gone. Here we go. This is what that we're trying not to happen, but let's see. So we do have a minikube running. Yeah, that's it. Let's check. Nope. There we go. So minikube is already running, so you don't have to wait. I have a few pods running already. Let's see what we have here. kubectl get pods. Here we go. So I already have a bunch of stuff here, but we can just launch them all together. So let's see. I do have. Here we go. So let's say that we don't have our fetcher service. So like I said, we're fetching transactions from an exchange and putting them on an SQ message queue. So let's launch NSQ, which should be already running, but this is just for kicks. Let's try it out. So basically I'm using Helm upgrade, so I don't even know what NSQ is supposed to do, so I just launch it. I can actually do a dry run just to see what the hell it will do. There we go. So let's launch the fetcher service. Excellent. So it's not our team's service, so looks good. Let's see if it's running. To the right, can you see? Okay. There we go. Let me just put it a little bit smaller. Just a moment. Just a little bit smaller. Here we go. It's okay. Okay, cool. Excellent. So it should be running. Let's get some pods. Okay. Seems it is. So it's saying it's fetching stuff. Let's believe it. We'll just check it out. We can actually see that it's doing something. Yeah. So this is, it hasn't consumed 2,000 messages now, but you guys need to believe me. I had this running yesterday, so has been doing some stuff. Okay, so let's see our storage service. So basically, our storage service is something very simple. You guys can see. Let's try and put this a little bit bigger. So it's basically a script, nothing fancy. It just reads message from an SQ and tries to put it on a Influx database. So let's launch Influx. As you can see from this command, I don't even have access to the code. Like I said, you've probably not seen this. Here we go. Like I said, you can actually package and share your Helm charts. So I'm using one from the community. So a good idea is to try and see what the hell this is going to do. So very nice. It will launch a container, provides me some information where everything is going to be run. I can actually see what it will do. It will launch a config map. It will launch a deployment. There's some extra space. So I'm happy with it. I'm going to launch it. Actually didn't do anything because it was already running, but we can move on. So now we're going to launch our service. It's store, so we do have a Helm chart for this. Let's see what our Helm chart does. So basically our Helm chart will launch a deployment. We'll have one replica. We have defining the strategy for an upgrade. It does have a checksum for some configs, a container that we're going to use. It has some variables, has some secrets, how to connect. Everything looks okay. We did dry run. It actually said it doesn't have any problems. So let's launch this. There we go. Should be okay. Let's see if it's consuming. Actually still launching, so new version. Here we go. It launched okay. So one of the issues of doing live stuff is that I'm connecting directly to an exchange, which means that I'm constrained by whatever who's doing transactions to have something here. Fortunately, someone did a transaction on Bitstamp, so excellent. Here we go. So let's now check a little bit of Skaffold. Like I said, we've already seen what a Skaffold YAML does. Let me put this a little bit bigger. Yeah. There we go. Let's put it again, see it better. So it's basically the one that we've seen before. So this will handle for me the actual build and deploy of the application. I'm saying what's the image that I want, some tagging. You can there's a bunch on the documentation what you will tag, like the commit, something custom, and I'm actually having a stage to deploy and saying, okay, so shards, the shard for my application lives over here. Just please deploy what I want. If I had a values file that for the purpose of the presentation I don't have, I could actually specify this to have like passwords or some kind of config that I require. So basically, let's try and do a build. So this Docker tag is basically just something custom that I want. So I already had the image built and cached, so we don't have to wait for a long time. So basically just saying, trying to build, everything built okay. It's trying to push the images, okay, seems fine. So I didn't have to do much. I can actually do a scaffold deploy, and basically scaffold will just look at the latest part of the shard of the configuration and just launch it. And I can do it all in one run, where I can basically just call scaffold run, and it will do all the stages just for me. Trying to build it again. Everything looks okay. Trying to push it. Should be fine. GitLab doesn't ruin everything. And it will try and deploy it. Okay, excellent. So it did a lot of stuff for me. So we have some of our tooling. Like I said before, it's a shame that we can't see, but we'll try and manage this. So when you start using Helm, you start having about you don't need to actually spread in files. It could be just a YAML file, but yeah, it's a good idea to spread stuff so you don't have like a huge file with 1,000 lines worth of configuration. So one of the things that you start to actually do a lot is do the same thing over and over and over again. So you have a bunch of applications, you do have to do deployments, you have to do configs, you have to do have secret services. You will start to have a bunch of files looking like this, which probably you can't see, me neither, but you have to trust me. But let's see if I can show you better here. So probably a shard somewhere. Yeah, let's see this one. Internet, please. Here we go. I'm trying. Yeah, resolution is not that good. So, but you can basically get the gist. So you do have, yeah, work with me, please. So basically, you do have deployments. You have some templating here. You can actually iterate over arrays. So it looks, it's promising, but you will quickly find out that you will have loads and loads and loads of files looking like this. If you start to having dozens, hundreds of services, you will keep writing all of those. So we're software engineers. We can try to be a little bit smarter. So you can basically, with Helm, you can actually do some abstraction. And again, this one you can do. So basically, you can start defining. Helm actually allows you to define resources that you can include in other files. So you can actually do something like, let me define a deployment, a standard deployment for me. So a deployment for me is basically almost always the same thing. I do have, let's use for the sake of example, a container that will have a tag. It will have secrets, it will have configs, it will have a defined number of replicas, it will have labels, and I can put that in a template. After that, on my deployment only needs to look something like this. I need to include, so my application needs a config map, a secret, and a deployment. I can actually reference what I have defined before. I'll show you better in a second. And I say, and the values come from whatever data structure that I want. And so a data structure, an example of a data structure, DSL that you can define on your own companies can be something like this. I do have the name of my applications. I can have my configs, the Docker image that I want is this one, the tag that I want is this, what it will be called. So basically, this can be defined once, shared with all of your teams. You can document a small DSL, and now you can actually go to your teams and say, okay, so now do you have documentation for how to build a deployment? For example, you don't actually need to know all this lingo. You just need to know that this will render a deployment or a service or whatever it is. And you are constrained to only writing a few lines of code instead of hundreds and hundreds like those. Let me just show how this works. So I do have here something called stored enhanced. Let's see what this does. So this basically is this is doing is using actually these two config files. So I don't have on my chart, I don't have anything else. I don't have this part, I only have this. It's exactly this code that I'm trying to render. So that everyone can see, and it will produce all of this without me even knowing what a config map is, what a deployment is. Here we go. Seems to be okay. Let's try and deploy this. Come on. Here we go. One thing that you're seeing here, it's trying to fetch. Let me just. is trying to fetch something called Bootstrap, some package that I created. You can actually see that you can reference it on your own deployments. You won't be able to see it. Come on. So let's just see if my service is running okay. Seems to be. Excellent. So it's fetching stuff from Bitstamp. Someone just bought some Ethereum. Cool. The way that you can start doing this kind of stuff. You also have, like in any other programming language, you have a requirements file when you can specify dependencies. Here we go. You can see something. Excellent. So basically, you can actually define some kind of abstraction you can include on your own applications, and basically, you then only have stuff a lot simpler. It's the thing of not being able to do, and your store enhanced will actually define a bunch of. This is it. That's the only thing that you need to write. It's stuff like this. So it becomes a lot simpler. You can actually share your code with a lot less friction, and have your projects up and running. So here we go. Hope some of you found this more or less interesting. Does anyone have any question? Sure, go ahead. How so? Yep. Yep. Oh, I never use customize. So like I said, we started in the traditional way, just defining our own stuff. We moved to Helm, and we started writing the same files over and over again. And then customize was not a thing at a time, so we basically started building that kind of stuff, which internally we called Bootstrap. So basically, people don't even know, or it's not they don't know, they don't have to care about how many deployments they have to write. So basically, they just reference Bootstrap, give a config file with, I don't know, 10, 15 lines, and just go. Should. No, I haven't. We haven't got it. Yeah. 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 Okay, cool. I'll should check that out. We had some investment done in this, so we're sticking with it for some time. Anyone else? Oh. Thank you all for coming.